In this video, we will explore the transformations of a piecewise function. There are two main types of transformations, rigid and non-rigid. You may have heard of these types of transformations before by these or other names, but the rigid transformations are known as translations and reflections. Maybe you've heard of them as the slide or flip. Non-rigid transformations are in the form of stretches and shrinks. And you may have also heard of them referred to as a dilation. Each type of transformation could be in a vertical or horizontal direction. To follow along in this exploration, open a web browser to the following web address. It should take you to a page that looks like this. What we will do is move these sliders to explore the different types of transformations. Keep in mind, I want you to think about the following questions. What do you notice and what do you wonder? What kind of generalizations can you make? Let's start by exploring with the sliders H and K. So as I move the slider, first of all, you'll see that there's actually two graphs on the screen. The blue dash graph is the original graph of the function f of x, as referred to here in this Desmos file. The green graph is the transformed function, g of x, based on f of x. So as I move the slider for h, what do you notice and what do you wonder? What kind of generalizations can you make? I'm going to do the same thing for K. What do you notice? And what do you wonder? Can you make any generalizations? Hopefully you notice that H transforms the graph with a horizontal translation, and K transforms the graph with a vertical translation. So consider this example. If H is -3 and K is 1, how will the graph move? Think about it and try it for yourself. So by changing the slider for H to -3 and K to +1, we can see that the graph has been moved to the left 3 units and up 1 unit. Let's look at one point in particular, the maximum point on both graphs, both the original function and the transform function. So if we were to look at this point by point, we see that this point 7, 8.5 has now become the value 4, 9.5. All I've done here is I've copied just the important part of the graph, enough so that we can see, first of all, that there was this movement to the left 3 units, or in other words, that -3, and up 1 unit, or +1. And we've seen these values before. H is -3 and K is +1. So if the entire graph shifted this way, we can also consider point by point, how each point has changed. How could we state 7 has changed in a way to become 4? Well, 7 minus 3 gives us 4. And what about the change from 8.5 to 9.5? Well, 8.5 plus 1 gives us 9.5. And again, H is -3 and K is +1. Let's consider another example. And this time, I have just taken a screenshot of a transformation that I've created by moving just the sliders H and K in the Desmos file. And the question is, how was the graph transformed, specifically from the blue dashed line to obtain the green solid line? Do you see that it's been moved down and right? So pick an important point. It could still be the maximum point. It could be an endpoint or any other turning point. This time, let's pick the endpoint just to do something a little bit different. Let's focus on these two endpoints here. So to go from the blue dash line to the green solid line, we would move along the grid down 4 units and right 5 units. And this is one way to describe the transformation, as a translation down 4 and right 5. So what was H and K? If you think you know it, you can always go to the Desmos file and test it out. But K should be -4 and H should be +5. Try it for yourself and see. And there's one more place that we see H and K appear, and that's here in the equation form. I have my screenshot so I can write over top of it. But what we're going to do is substitute these values for A, B, H, and K into this equation. All right, so A is 1, and that's being multiplied, and 1 times anything doesn't change that thing. B is also 1, and that's being x minus h, rather, is being divided by 1. So again, it's not going to change anything here. H is 5, so we'll replace h with 5. And k is -4, so we'll replace that with a -4. Simplifying, cleaning that up a little bit, we would get g of x equals f of x minus 5 minus 4. And what do you notice and wonder here? Remember, this graph moved down 4 units and right 5 units. How is that expressed in the equation? Down 4 appears here in this part of the equation. Right 5 appears here. Don't get confused by the minus sign as part of the rule for the transformation. This is still to the right 5 units. Try some other examples in the Desmos file, just so that you're comfortable with this and the different types of translations when sliding H and K.